So before I explain longest job first algorithm, let me recap you shortest job first algorithm. So this was a non-preemptive algorithm. Okay. So what do I mean by non-preemptive algorithm? So once a process is picked for execution, that process is given to CPU and the process is executed till its completion. All right. There is no concept of preemption. All right. Once a process is finished, then only new process is scheduled. This is called non-preemptive algorithm. And one more thing, if you remember, how did we pick the right process which will be scheduled next? So across all the available processes, your scheduler will be finding that process which requires the least amount of time. All right, least amount of burst time, and that process will be scheduled next. Let's say there is P1, P2, P3, P4. Let's say these are the available processes, and let's say this takes 1 unit of time, this takes 2 unit of time, this takes maybe 10 unit of time, and this takes maybe 0.5 unit of time. So in this setup, your scheduler will be choosing P4 for the next scheduling because this P4 is having the least amount of burst time. Okay. So if you remember, there are two issues. One is starvation. So in the context of shortest job first, which kind of processes will be facing this starvation? So those processes with the higher burst time, those processes will be facing the starvation. Why so? Because your scheduler will always be prioritizing those processes with the shorter burst times. All right. So even if a process has come very early, but if its burst time is very high, that will not be prioritized. Okay. So that process will end up starving. So here in longest job first, which kind of process will be suffering from this starvation? Those processes which is having the least amount of burst time, those kind of processes will be facing this starvation issue. Why so? Because always your scheduler will be prioritizing those jobs which is having highest burst times or longer burst times. All right. Even if one process has come very early, if the burst time of that process is very low, that will not be prioritized. So that kind of process will be facing this starvation issue. And one another issue is the burst time. So before scheduling, we really do not know what is the exact burst time a process will be taking. All right, that was the major issue that we discussed in shortest job first and shortest remaining time first. Okay, so what was the solution? We will have to predict the burst time of a particular process. So if you have followed my previous videos, after shortest remaining time first algorithm, I have explained how can you predict the burst time of a particular process. So here also I have already explained this starvation and this burst time issue. Both of these issue will be persisted in longest job first algorithm as well. All right. So let me take a copy of the question and let me make a paste. All right. So okay, here. All right. Now let's draw the Gantt chart. Let's say this is the Gantt chart. Okay. At time t equal to 0, you are standing. Let's say at time t equal to 0, which process is available? That is process 1 only. So you will have to schedule process 1, and this is non-preemptive. You will have to run till its completion. So 0 to 6 is process 1 will be running. So by the time you have reached this time t equal to 6, in your system, this process P2, P3, P4, all of them are available. Now, this process P1 is gone. This is completely executed. Among this process P2, P3, P4, now you will have to schedule that process which is having the highest amount of burst time. That is process P3. Let's schedule process P3 here. Okay. What is the burst time? That is 8. So 6 plus 8 is 14. Okay. 1 is done. P3 is also done. Now the remaining processes are P2 and P4. Between P2 and P4, which process is having higher burst time? That is process P4. Schedule process P4 here. Okay. And run till its completion. So what is the burst time? That is 3. 14 plus 3 is 17. Now only one process is left. That is process P2. Write down process P2 here, and 17 plus 2 is 19 because 2 is the burst time of process P2. So let me complete the entire table. Let's say this is completion time, this is turnaround time, this is wait time, and this is response time. Okay. So while filling completion time, the suggestion is you will have to come from the right side. Okay. So when is process P2 finished? That is time t equal to 19. Okay. Then process P4 when it is finished at time t equal to 17. Write it down. Okay. Then process P3 when it is finished at time t equal to 14. Now come to process P1. Okay. When it is finished at time t equal to 6. So we know turnaround time is the difference between completion time and arrival time. So 6 minus 6 is 0. Okay. 19 minus 1 is how much? 18. 14 minus 2 is how much? 12. 17 minus 3 is how much? 14. So what is the wait time? So let me explain the wait time. Let me give you a recap. So turnaround time we know that is wait time plus burst time. So what is the wait time? Wait time is the turnaround time minus burst time. So turnaround time minus burst time. So 6 minus 6 that is 0. 18 minus 2 that is 16. Alright. 12 minus 8 that is 4. 14 minus 3 that is 11. So now let's calculate the response time. So the suggestion is, while calculating response time, you will have to come from the left side. If you forgot about the response time, so response time is the time duration between when your process is scheduled for the first time and when your process has arrived in the system. Okay. So when is process P1 is scheduled for the first time, that is time t equal to 0. When it has arrived, time t equal to 0. The difference between 0 and 0, that is 0. Now keep on coming like this. Let's say this is process P3. When it is scheduled for the first time, that is time t equal to 6. Alright. And when it has arrived in the system, that is time t equal to 2. So 6 minus 2, that is 4. Now come like this. When P4 is scheduled for the first time, that is time t equal to 14. And when it has arrived in the system, that is 3. So 14 minus 3, that is 11. Okay. Let's come here. When is P2 scheduled for the first time, that is time t equal to 17. And when this process P2 has arrived in the system, that is time t equal to 1. So 17 minus 1, that is 16. So this is your response times. Alright. So now let's calculate the schedule length. Okay. So what is schedule length? So schedule length is the maximum completion time across all the processes. So that is 19. If you see here, that is 19 minus minimum arrival time across all the processes. So this is the minimum arrival time. Let's say that is 0. So 19 minus 0, that is 19. So now let's see throughput. Okay. So throughput is, if you remember the formula, that is number of processes, okay, divided by schedule length. So what is the number of processes here? That is 4. What is the schedule length? That is 19. All right.